Before we look at examples, let's look at how we're going to identify horizontal asymptotes. So I put the notes at the very end of the page. To identify horizontal asymptote in the rational functions, you need to compare the degree of the numerator and denominator. Rational function is typically of the form f of x equals p of x over q of x. So some polynomial in the numerator, some polynomial in the denominator, where p of x and q of x are polynomials. Step to find the horizontal asymptote. First, you're going to compare the degree of p of x, which is the numerator, to the degree of q of x, which is the denominator. Let n be the degree of the numerator and m be the degree of the denominator. Determine the horizontal asymptote based on the degree n and m, which is the degree of the numerator and the denominator. If n is less than m, which is the degree of the numerator, is less than the degree of the denominator, the horizontal asymptote is y equals 0, or the x-axis. The function in this case approaches the 0 as x goes to infinity. If n is equal to m, or the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is equal to y equals a over b, where a and b are the leading coefficients of p of x and q of x, respectively. This is q of x, not a of x. For example, if you have, if p of x equals 3x squared and q of x is equal to 2x squared, in other words, our polynomial looks like this. F of x equals to 3x squared over 2x squared. Then the horizontal asymptote will be y equals 3 over 2, which is the coefficient of the numerator divided by the coefficient of the denominator. Last but not least, if n is greater than m, or in other words, the coefficient of the numerator is bigger than the coefficient of the denominator, then in this case we say there is no horizontal asymptote. However, if n is equal to m plus 1, in other words, if the degree of the numerator is 1 bigger than the degree of the denominator, then the function has an oblique or slant asymptote instead. And we can find that asymptote by performing polynomial long division. But in our course, we're not going to get into the part where we're going to find the oblique asymptote, so that is not a requirement. Let's go back to the examples. Examples. Find the horizontal and vertical asymptotes of the graphs of the given functions. So first one, f of x equals to 3 over x minus 12. First, let's find vertical asymptote. As you see, there is no factorization that can be done, so we're going to proceed. There are no common factors between the numerator and the denominator, so we cannot reduce the expression. Now we're going to take the denominator, x minus 12, and we're going to make it equal to 0 and solve. So if you solve this, you get x equals 12, and that is basically the vertical asymptote. So that is our vertical asymptote. In the case of horizontal asymptote, notice that the degree of the numerator is 0, because if there is a constant, there is always an x to the 0 power. The degree of the denominator is 1, so the degree of the numerator is less than the degree of the denominator, which leads us to this rule right here. And we know that the asymptote is equal to y equals 0. So the horizontal asymptote is going to be y equals to 0, or in other words, the x-axis. Second one, the vertical asymptote. Again, there is no factoring to be done, and there is no reduction to be done, so we're going to proceed to the next step. We're going to take the denominator, x minus 2, and we're going to make it equal to 0 and solve. If you solve this equation, you get x equals 2. That is the vertical asymptote. The horizontal asymptote, notice how the degree of the numerator is 1, the degree of the denominator is 1. So in this case, the asymptote is equal to the coefficient of the numerator divided by the coefficient of the denominator, or in other words, y equals 4, and that is our horizontal asymptote. The third example, the vertical asymptote. First, let's factor the numerator and the denominator. So we get f of x equals 2. The numerator does not factor. The denominator can be factored into x minus 1 times x plus 1. There are no factors to cancel between the numerator and the denominator, so we're not going to be able to simplify this expression. However, we're going to make each factor in the denominator equal to 0 and find the vertical asymptotes. So x minus 1 equals 0 will lead to x equals 1. That is our vertical asymptote, the first one. And then x plus 1 equals 0 will lead to x equals negative 1, which is the second asymptote. The horizontal asymptotes, notice how the degree of the numerator is 1, the degree of the denominator is 2, so numerator is less than denominator, which will lead to the horizontal asymptote equals y equals to 0, or the x-axis. Last but not least, we have f of x equals 3x squared minus 4 over x squared minus 5x minus 14. I see that we can factor the denominator, so we have f of x equals to 3x squared minus 4 over x and x. We need two numbers. Their product is negative 14. Their sum is negative 5. The answer is negative 7 and positive 2. Now, there are no factors to cancel from the denominator and the numerator. So we're going to proceed to the next step, which is to find the vertical asymptotes. We're going to make each factor equals to 0. So x plus 2 equals to 0 will lead to the vertical asymptote x equals negative 2. And the factor x minus 7 equals to 0 will lead to x equals 7, which is another vertical asymptote. So we have two vertical asymptotes. The horizontal asymptote, in this case, the degree of the numerator is 2. The degree of the denominator is 2. So the horizontal asymptote will be y equals to the leading coefficient of the numerator divided by the leading coefficient of the denominator, or in other words, y equals 3, and that is our horizontal asymptote. So these are basically how you're going to figure out the vertical and horizontal asymptote. Now that we know all of this information, we can reverse the process and we will be able to find rational functions based on information given or based on graphs given. Let's try the second example. Find a rational function that satisfies the given conditions. Answers may vary, but try to give the simplest answer possible. We have two vertical asymptotes and we have an x-intercept. So we're going to assume